It will be
Okay.
live in any minute.
Okay. Are we live? Good morning, everyone. Am I audible? So I can see Harshita and Siddhant. Where are the rest of the students? Okay, let's wait for 5 more minutes then. All right, I think we can start for the session. All right, let me quickly share my screen. Let me know if it's visible. Okay, can you please open Jupyter Notebook in the meanwhile? Create a folder called uh, Python for Business Analytics. By the way, which cohort is this? This is cohort 15, right? Or 14? Okay. Create a folder and open a Python notebook. All right. Let me know when you are on the screen. And let us quickly recall everything that we covered in our previous session on basics of Python. So what are the things we covered in basics of Python? You all remember? Are you all practicing? Are you all practicing Python once in a week at least? Anyone? Yes. Harshita is saying a bit. Siddhant is saying yes, practicing. Okay. So what did we cover in basics of Python? We started with data types, right? Data types and variables. So no. And under data types, what all data types we covered? We covered integer, yes. Then string, then Boolean. Yes, and we also saw some advanced data structures like data types like list, tuples, and dictionaries, right? And I guess in the case study also, we made maximum use of lists and dictionaries. Yes or no? Correct. And apart from this data types and variables, we also saw Python constructs, right? Some of the Python constructs or Python control flow constructs. Yes, we saw the conditional statements, right? Under conditional statements, we saw if, then if else, and if elif else, right? Next, apart from conditional statements, we also covered loops, right? Loops. And in the loops, we saw for loop and while loop. So no. And finally, we saw functions. Yes, the user-defined functions, if you all remember. What is the keyword that we use? Def, right? And if you all remember, I also told you that in our upcoming sessions, that is this Python for business analytics session, these are the data structure that will be needing a lot, right? So have you all practicing at least list and dictionaries? Forget about tuples. At least list and dictionaries. Are you all comfortable now? Yes, Harshita is saying yes, Siddhant is saying yes. Perfect. Now, let me give you some brief idea about how these sessions would look like. Okay. So we have 4 sessions in total. Yes or no? So we will follow the same pattern. When I say same pattern, in the last session, we will reserve the last session for the case study. Okay. So in our previous basics of Python sessions, the last session we reserved it for the case study. Was the case study helpful when you attempted your assignment? Yes, no, maybe. Was it helpful? Okay, only Harshita is saying yes. All right. So we'll do the same thing. We'll follow the case study in the last session. And the rest of the 3 sessions, the first session we will dedicate to NumPy, the NumPy library. Second, we will dedicate to pandas. Third, also we will dedicate to pandas and visualization. Some visualization libraries, there are some visualization libraries like matplotlib, matplotlib. Okay. And the 4th session, like I said, will dedicate to the case study. Okay. Getting it? Now, in these 4 sessions, these are the 3 libraries that will be developed at NumPy, pandas, and the visualization libraries like matplotlib. And if time permits, we'll also cover C14. Okay, let me write it down. Matplotlib and C14. SEABORN, C14. These are the 2 libraries meant for visualization. And then we have NumPy and pandas. Now, in real time, only this section is something which you all would be working on. Only these 2 parts, pandas and visualization libraries. Mostly you will be dealing with pandas. And that's the reason why we have kept 2 sessions on pandas and only 1 section on NumPy. Now, in a lot of institutes, this NumPy is mostly skipped. Okay, I'm not going to do that because this pandas library, okay, this pandas library is built on top of NumPy. Without NumPy, you cannot use pandas. Okay, so these are the 3 libraries out of which pandas is something which will be using it in our daily lives. When I say using it in our daily lives, it means that we basically use pandas for reading all the CSV files. Okay. Then after you read the CSV file, we do all sort of data analysis, right? So all the data manipulation is something which is again done using pandas. Then you have all the exploratory data analysis. Let me call it as EDA, exploratory data analysis. Okay. And data engineering. So these are all the tasks. Don't worry, we will cover all this. Data engineering. Now these are all the tasks which can be performed using just these pandas library in hardly say 1 or 2 line of code. That's it. You don't have to write loops. You don't have to write the if-else statements. Yes, you would be needing them, but you don't have to write it so much. The pandas library has a lot of functionalities available to perform all these tasks within a line or 2. Okay. Now, in order to do all these tasks, it's very important to understand what goes behind the scene, under the hood, and NumPy is something which is responsible for all of this. Okay, so that's the reason why I always dedicate the first session on NumPy. I don't cover a lot of things, but I give a little idea and I prove it in the Panda session how NumPy was useful in understanding or performing certain tasks. So always remember NumPy, although it's not covered, although we don't use it a lot, but it's the most important library, which all these pandas and then matplotlib, they use it uh, uh, behind the scenes. Okay. All right. So let's, sorry, not the text. Yeah. So let's begin with, this is day one, right? So day one will cover the NumPy library. Okay, let me quickly write it down. NumPy. Basically, this NumPy stands for numerical Python. So this NUM from numerical and PY from Python. Okay, this is how the name has been derived. So NumPy stands for basically numerical Python, and it is responsible for all the mathematical and as well as scientific computation. Okay, and the data structure that is associated with NumPy is array. How many of you have heard about this term array before? If you are from comp or IT or have done engineering, you might have heard about this term array. Yes, Arshita is saying yes, Siddhant is saying yes. We have one more, Venkatesh. Venkatesh, are you there? Okay. So array, you might have heard, you all might have heard about it, right? So array, you might have heard that it's a data structure which is used for storing data. Yes, something like, I mean, this sort of definition you might have heard it, right? Yes or no? So this array forms the basic or the central structure of this NumPy library. All right. So NumPy, what you can do is you can have one-dimensional array. One-dimensional array. You can have two-dimensional array. You can have three-dimensional array. When I say one-dimensional, that means just like list, you can have all the elements. Yes, all the elements inside inside this data structure, right? One by one. This is one dimensional. When I talk about two dimensional, it is very similar to the matrix. You might have done matrices in your school, right? School or college. You have matrices like, let's say you'll have numbers like this, 4, 5, 6. So this is what is the dimension of this array? 2 by 3, right? Yes or no? So you have 2 rows and 3 columns. Getting it? So what is the dimension of this array? This matrix is 2 by 3, but this is an array, right? So you have 2 dimension. One is the row and other is the column. So this is 2-dimensional array. Okay, what about 3-dimensional array? Can you tell me how would it look like? Any idea? Can you make a guess? Yes, no, maybe. Three rows and column? You meant to say just like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 rows and 3 columns. Is that what you're saying, Siddhant? Yes. See, again, if you see here, if you notice, this is a 3 by 3 matrix. Okay, this is a 3 by 3 matrix because you have three elements in each in the row and columns, right? But the dimension is still 2, no? The dimension is still 2, row and column. This matrix is 3 by 3. I agree. But if you ask me if what is the dimension of this array, this is a 2-dimensional array. You have row and a column. How would a 3-dimensional array look like? I'm not asking the matrix. I'm not asking about how a 3-dimensional matrix would look like. I'm asking how would a 3-dimensional array would look like? Yes. So let me tell you the difference. So let's talk about the first 1-dimensional. So let's say you have a 1D array. 1D array basically it's 1-dimensional array. So you will have data stored like this: 1, 2, 3, 4. Okay, the axis is 0. Okay, axis is 0. What is the shape? Shape is 4 elements. Venkatesh is asking, will length, width, height fall under 3D array? Yes, somewhat similar. Somewhat similar. We are going towards that only. Okay, so this is 1-dimensional array. Then we talk about 2D array, basically 2-dimensional array. So 2-dimensional array, we will have data stored something in this fashion. Somewhat like this: 1, 2, 3, 4, 5, 6, 7, 8. Okay, we know that this, I mean, whenever you go into this direction, you have axis 0, and whenever you go like this, we call it as axis 1. If you talk about mathematics, you have x-axis and y-axis, right? This is x, this is y. When you talk about just one-dimensional coordinate system, you will have only x-axis, right? Yes or no? If I talk about 2-dimensional, you say this is x-axis and this is y-axis, right? And if I ask you, what about a 3-dimensional coordinate system? You will have one more axis like this, right? And you will call this as x, you will call this as y, and you will call this as z, right? Correct or no? So similarly, the 3-dimensional array, the 3-dimensional array would have these axes, basically axis 0 and axis 1, whereas this would be followed by multiple somewhat like this. You will have a 2-dimensional array, another 2-dimensional array. Yes, then you will have another 2-dimensional array. So basically, collection of 2-dimensional arrays. Getting it? This would be called as axis 2. So this is your axis 0, axis 1, and this is axis 2. Getting it? So let's call this 7, 8, 9, then you'll have 10 here, 11, 12, then 13, 14, 15, 16, so on. Understood, everyone? Yes. So three-dimensional array is basically a collection of two-dimensional array. Okay. So what is the shape of this one-dimensional array? The shape is 4. What is the shape of this two-dimensional array? Yes, 2, 4. Right? 2 rows and 4 columns. Whereas, what is the shape of this three-dimensional array? Yes. So you have 4, comma. Yes, 4, comma. Okay, you can call this as 2, 3, 4. Right. Understood, everyone? Understood the difference? All right. So if we talk about, now this was all conceptual. If I talk about arrays as far as Python is concerned, so they are very similar to, I mean, they look very similar to your list, but there's a huge difference between a list and a NumPy array. Okay, let's create a NumPy array from. We will understand the difference between these two, and we'll understand what are the advantages of using array instead of list. Okay. See, ultimately, all these arrays, all this list, all the dictionaries, why are we learning them? They all contribute towards creating a data frame. Okay. If we don't understand this part, we won't be able to manipulate or play around with the data file that will be data frame that will be creating from the CSV files, or let's say they will ask you to connect to a database and then read a particular table. So everything would be read as pandas data frame only, be it a CSV file. Can create a pandas data frame using a CSV file. You can create a pandas data frame from a DBMS table. You know what DBMS table is, right? SQL table basically. Then not just CSV, then you have other formats like Excel SX. Then you have XML. Yes, we saw how XML file looks like in our previous session, right? When we started understanding about learning about dictionary. Then you now also have option of reading the data from PDFs also. Earlier, this support was not there in pandas, but you can use a lot of data sources, not just CSV. There are a lot of sources from which you can create a data frame. Now, once you create a data frame from all these sources, the underlying data structure that is utilized behind this data frame is all this. Basically, it is mostly array. But you can also create a data frame using a list and dictionary also. Okay. When you create a data frame using a list and dictionary, what happens is this list and dictionary gets converted into an array, and then this array is converted into a data frame. And all these things goes behind the background. Okay, I'll show you how to create a data frame from list and dictionary in the next session. But for now, let's focus ourselves on arrays right now. Okay. I just explained this to you because we might have a doubt that why are we learning all these data structures. Okay, you will understand, you will get the hold of it, of all these things in pandas. Okay. All right. So let's see how we can create a numpy array from list. So let's say I have a list of weights of a group of candidates. So let's say 52 kg, 62 kg, 73 kg, and let's say 64 kg. Okay, so this is basically a list. Okay, if I check the type of this variable weight, comes out to be list. Right now, let's create a numpy array. So what we will do is we'll say weight underscore array. Just to I'm giving this array here just to identify that this is an array, and I'll say numpy dot array, and in here I'll give or I'll pass this list. Okay. Now this will throw an error. What is the error? It says name numpy is not defined. Okay, see, again we are following the same approach. We'll make mistakes and we'll understand and we'll rectify it. Okay, this helps you understand to taking care of the code. Now what is this error? It says name numpy is not defined. Have we defined numpy anywhere? We are using it in our program, but have we created any variable called numpy? Are we storing it somewhere? No, right? But numpy, as far as we understand so far, numpy is a library, right? So whenever we want to use a library in our program, what we need to do, the first thing is we need to import that library. Okay, we need to import that library. So for that, I'll write something called as import numpy. Okay. So let's run this, and let's run this now. And if you check the type of this weight array, it comes out to be numpy.nd array. Basically, this is an array, is what it says. Okay. And if you try to print it, this array, yes, it looks very similar to list, isn't it? Yes or no? See, if I try to print weight, see, it's a list, right? But what is the type of this list? What is the type? Let's print it. Print this as well. It says it's a list. But when it comes to this array, it prints the same thing, but it says it's a numpy array. Yes. Now, whenever I want to use numpy, I'll have to write this numpy completely, right? So what programmers do is they create an alias of a library. So this numpy, we will say import numpy as np. So instead of using numpy, instead of writing np or numpy completely every time, we can choose to write just np. Okay, so there are particular standards. Now these standards are not defined, but these are very common standards that everyone uses. So we import numpy as np always. You can choose to write any keyword for that matter. It's not that you should always use numpy, but numpy is always imported as np. Similarly, Pandas is always imported as PD. Okay, and matplotlib, which is a visualization library, is always imported as PLT. Okay, PLT is basically matplotlib. We'll see more on this in our next sessions. I'm just giving you an idea for now. So we have imported NumPy. We are writing it like this. This is basically, this is called as alias. Okay, we are creating an alias of our library's name so that we don't have to type this every time. Getting it? Okay. So instead of, let me run all this again. I'll go to kernel. I'll say restart. Restart and clear output. And you'll get to see that it gives the same result. So I'm running it again. I'm importing NumPy as NP. I am printing all the weights. I'm not using NumPy here. This is basically a list. And this is creating array, NumPy array basically from that list. So let's quickly run this. See, it still gives the same result. Understood? So this is the keyword. This is the NumPy library that we use, and under that NumPy library, this is the method np dot. This array method is something that we are using to create a NumPy array from a list. Okay. So far, what we have done is we have only created. A one-dimensional array. Okay, we have only created a one-dimensional array. Now, what are the difference between a list and array? We still need to understand that part, right? Why should we consider using an array instead of list? So there are three important things that you need to understand. That arrays, you might want to write this down. Arrays occupy very less memory. Okay, they work faster than lists, and are convenient to use. So we'll understand all these three with an example. Okay, so let's focus on the time part, the faster part. Okay, what we will do is we will create a list first. Okay, let's create a list and see how much time it takes to create a particular amount of list. Okay, so I'll give percent time here. Let's create for I in range. Let's take this amount of range. Okay, this amount of numbers, and I'll say let's call it as sample underscore list is equals to x for x, or let's say, let's take a power of it. Okay, x in can we create a list here? Can we? Or let me write it like this. Let me write it like this. Okay, sample is equals to for x n my underscore list. Okay, and I will create a list from this number. So what I'm doing is I am creating a list which has numbers from 1 to what is this? This is 1 million or more than that. I think it's 1 million, right? Or 10 million. I think it's 10 million. So I'm creating numbers from 1 to 10 million. And I'm taking power of, when I say power of, I'm creating a square of each of these numbers. Okay, this is the operation that I'm trying to do. Okay, and I'm repeating it 10 times. I'm repeating it 10 times. This is just a mathematical computation that I'm trying to show here, and see how much time it takes to execute. Okay, let's hold on. I think I'll have to write it here. See, it's taking a lot of time. So it says wall time 6.6 seconds. So it took 6 seconds to basically create a range of numbers, a list of numbers from 1 to 10 million. Okay, this is the first step. And in the second step, what we are doing is we are taking a square of each of these numbers from 1 to 10 million, and we are repeating it 10 times. Okay, we are repeating the squaring operation of 1 to 10 times. Okay, so how much time it took? It took 6 seconds to execute these 2 lines of code. Okay, this is for list. Now let's perform the same operation, same kind of operation with array. Okay, so I'll simply say same thing for in range. Let's take range 10, and in order to take square of each of these numbers from 1 to 10 million, we don't have to write it like this. So array has its own way of doing things. So I'll say sample list is equals to let's create an array here first. np dot a range. Let's use the same number here. Okay, for now, what this does is this np dot a range. Range, we know what it does. Range creates number from 1 to this number. Sorry, 0 to this number. And this np dot a range again does the same thing, but it creates an array. Okay, numpy array range. This is what it means. np dot a range. And let's take the power of each of the numbers in this array. So in order to do that, we don't have to write it like this. This is a list comprehension, by the way. We just have to write it like this. That's it. Okay, it performs the same operation. And now let's see how much time it takes. Okay, I need to use in here. Okay, let me write % time so that we get to see the time. Yeah, how much time it is taking? Yes, to perform the same operation, basically creating numbers from 1 to 10 million, and for each number we are taking a square of it, and we are taking the squaring operation 10 times. Okay, so this was for list and this is for array. So how much time it takes? For list, it took 6.6 seconds to execute, whereas for array, it's taking 33.9 milliseconds. So which one is faster? Mine took 11.5 minutes. That's okay. I mean, it depends upon system to system, obviously. But on the same system, if you compare, on the if I'm comparing on the same system, if I'm comparing the execution time of list and execution time of array, array comes out to be much faster than list, right? Whereas if you can compare, this is 6 seconds and this is 33.9 milliseconds. Yes or no? So how much is 33.9 milliseconds? Is it 0.3 seconds? Yes, if I convert this milliseconds into seconds, it comes out to be 0.3 seconds, right? So 0.3 and 6.6, huge difference, isn't it? 500 to 600 times faster than list. Now imagine if I would have created a data frame that has millions of rows and let's say somewhere around 100 columns and a million rows. If I use list as a data structure in my data frame, imagine if I'm trying to make any changes in my data frame or trying to manipulate the data frame, imagine the amount of time it would take. So that's the reason these arrays are used. This is one of the very important point you need to understand. This is the main reason why arrays are used behind the scene in data frame. Understood? Now, apart from this, not just the time, if I talk about the convenience, see, I would just want what I wanted to do here is wanted to take square of, basically I was trying to take square of each of the numbers from 1 to this 10 million, right? For a list. Can we do it like this? Let's try to do it and see if it works or not. So I'll copy the same line, and instead of writing a list comprehension, what I'll do is I'll write it like this, but instead of using my array, this time I'll say my list star star 2. Star star 2 basically is exponential operator, right? So if I try to do this, it does not allow us to do it. We'll have to write it like this only. So which one is more convenient? I'm just writing my array star star 2 and it performs this exponential operation on each of this number by itself. But if I want to do the same thing as far as list is concerned, I'll have to write a list comprehension. So which one is more easy to use? Which one is more convenient to use? Arrays, right? Yes or no? So this is the main reason behind using arrays as a basic data structure for pandas data frame. Understood, everyone? Understood the importance of array? Perfect. All right. Okay. Guys, we have Harshita and Siddhant and Venkatesh this time. We had one more guy from our previous session. What was his name? He was from Python background. Did he? Yeah, Tamogna and Satya. They 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 uh they uh they made it. I mean, the case study that they did, they passed it, right? I've seen your marks. Venkatesh also scored good marks. Harshita has also scored good marks. Tamogna and Satya also scored good marks. Do you have any exam today? Exam or any other session? No. um. Okay. Still they didn't join, right? Chalo, anyways. Okay. So coming back to our program, coming back to our arrays. Uh, okay, if you all remember when we covered list and dictionaries, for each of these data structure, we also covered the methods that they offer, right? Can you name some of the, today is the first session on of term 2. Still they didn't join. Okay. Yeah, I'll talk to the administration. Anyways, let's focus here. So as far as list is or list or dictionary is concerned, they offer some set of methods, right? For list, can you name some of the methods for list? Can you mention some methods for list? Yes. Dot append. Do you all remember dot append? Yes. Dot len. I don't think we have dot len. Yes, len is an independent function. It can be used for dictionaries also. Yes. Dot insert. What else? Yeah, append and insert is the word. What else? Do you all remember? Count. Yes. Do we have reverse? No, we don't have reverse. Anyways, this was about list. Can you name some methods for string? Yes. We had capitalize. Yes. Then what else? Lower upper. What else? The most important one. We had strip also, right? Okay. What about dictionaries? Can you name some? We have dot items. Yes. Then you have dot keys. Then you have dot values. What else? Okay. So each of these data structure had basically a list of methods that they offer. So similarly, these arrays also come with a certain set of methods. Okay. Methods and attributes. Methods and attributes of arrays. Now, can anyone tell what is the difference between a method and attribute? Anyone? Yes. So if I ask you, okay, if I ask you, how do dogs communicate? Yes, how do dogs communicate? They bark, right? What about human beings? We talk, right? So as far as communication is concerned, uh, dogs bark, humans communicate, humans talk. So this barking and talking, they become independent methods of two different animals. The first animal is dog, second animal is human being. Okay, so we saw, right, for each data structure we had different methods. We can't use dictionary ka method with lists method. Yes or no? And vice versa. Right. So Siddhant is saying method are functions and attributes are variables. I won't say variables. The first one is correct. Methods are basically functions dedicated to that particular data type or data structure. As far as attributes, yes. So Harshida has correctly pointed out attributes are properties. So if I compare the same example, if I talk about the same example of dogs and human beings, so if I ask you how many legs are there as far as humans are concerned? Two. If I ask you how many legs do we have as far as dogs are concerned? Four, right? So if I talk about the leg as a property for each of these data structure or each of these animals, we get different output. Yes or no? So this leg is an attribute, right? And if I take communication, if I take communication as an attribute, you will get two different answers: bark and talk. Yes or no? So similarly, this these arrays, they have their own set of functions and they have their own set of attributes basically functions. So we'll take a look at uh, these methods and attributes of arrays. But before that, what we have done is we have only created an array from a list. Let's take a look at multiple ways of creating an array first, so that when we understand how to create an array, we will get into the methods and attributes of it. Okay, let me put that section in methods and array itself, because we will be using methods of arrays itself. So let's take a look at creating arrays. Okay, so we'll understand the methods that are utilized in order to create arrays. Okay, so there is a method called random. Okay, there is a method called random which helps us create a random numbers of basically random number. It helps us to create an array with the random numbers. Yeah. So let's create an array. Let me call it as my array, and we will use np dot random. Okay. np dot random, and in here in this I'll give the size of the array that I'm looking for. So let's create a 3 by 2 array. Let's print it. You see, you have 3 rows, first row, second row, and third row. Okay. So this creates a two-dimensional array. Two-dimensional array of 3 rows and 2 columns of random numbers. Okay, let me write another comment here. Let me add another comment. 2D array of 3 rows and 2 columns of random numbers. Okay. Now, when you use this random method, the numbers that you get here, the random numbers that you get is in interval. Okay, is in interval 0.0 to 1.0. Can you tell me what this means? What this means? Is 0 included or excluded? Harshita is saying included. What about others? Yes, it's included. What about this parenthesis? Is 1 included or excluded? 1 is excluded, right? So this random function that we are talking about, this random function, what it does is it creates random numbers in the half open interval 0.0 to 1. Okay, here 0 is included and 1 is excluded. Getting it? Understood this random function, this random method? Okay. Now there is another method, my array. Let's create another array with the same name and np dot random. Now here, if you notice, the numbers that you see, they are not normally distributed. Okay, these are just any random numbers between, I mean, in this interval. Okay, but what if I want to create? Let's say random numbers, and that those random numbers should have a uniform distribution. Okay, a normal distribution. So we call that method as rand n. This rand is for random and this n is for normal. Okay, so in here I'll give 4,2 as the size, and if you see here, these numbers are normally distributed. Okay, understood? So we have a 4 by 2 array here. Getting it? Now you might say, okay, what all these numbers that I'm getting to see, they all are float values, right? So let's take a look at another method that gives me an array with a proper integer numbers. Okay, so I'll say my array again is equals to np dot random dot rand int, basically random integer. Okay, so here I'll give some values. Let's say 2 comma 10 comma let's take 3 here. So what is this? So basically we are creating an array of 3 numbers, between 2 to 9. Okay, here 10 is excluded and 2 is included. Okay, so this will create 3 numbers between 2 to 10. 2 is included and 10 is excluded. So let's see, let's print it. You see 655, you can run this, you can keep running this again and again and see, you will get to see, you see 2 here, 2 is included and 10 is excluded. You will never see 10. The maximum number you will be seeing is 9. So keep running. You are seeing 9 here, but you will never see 10. Just keep running all this again and again. You will understand. So 3 is basically the number of elements that I want in my array. 2 is the included, I mean 2 to 10 is basically the range of numbers that I want, excluding 10 and including 2. Okay. There is another method that we have seen, which is this one, np.arrange. Yes, what this np.arrange does is arrange array is equals to np.arrange. This creates the numbers. Okay, the number from 0. By default, it starts from 0 and ends at this number. Okay, if you take a look at, one second, let me add more. Yeah. If you take a look at the document of this function, it says start, stop, and step. Start, stop, and step is something which we all have seen, right? So you can have start is equals to, by default, it starts from 0. You can choose to start from 10 or any number you want. But if you're not selecting anything, it starts from 0 by default. Okay. So I'll start from 10 and I'll stop at 1 million. And by default, the step is 1. You can select step 2, 3, whatever you want, whatever you like. Okay. So let's take 2 here. So what it does is it creates the numbers from 10 to 1 million, skipping 2 steps at a time. So you see here, see it starts from 10. Yes, 12, 14. This one, no, so it's taking 2 steps at a time. And if you take a look at the last 3 numbers, again, you will get to see 2 steps. Understood? So we have seen random and arrange so far. Okay. Let's now take a look at the attributes. Okay. Attributes. Now these are very important attributes because in, let me write it down first. Yeah, because these attributes are something which pandas borrows. Okay, you can use the same attributes in pandas also. Okay, please pay attention here. So let's create a variable called quantity, and we will use np.array, and in here we'll pass two lists. Okay, or instead of saying list, let's just pass two tuples. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and if you try to print quantity, you will get to see two. Yes, it's a two-dimensional array. Now, if you're not sure what is the dimension of an array, there is a function, or there is an attribute, sorry, not function, attribute called ndim, It tells you what is the dimension of that particular array. You can take a look at the doc string. It tells you what is the dimension of that particular array. Okay, now ndim is something which can be used in pandas also. Okay, then there is something called as item size. Yes, how many elements do we have in each dimension? So there are two dimensions, right? So how many elements do we have for each dimension? 4, right? That is what item size tells you about. This is something which we don't use in pandas. Name is used. Let's take a look at another important attribute called dtype. Now, what is the mistake that I've done here? Dtype is not a function. Okay, it's an attribute. Item size, it's not a function. Name is not a function or method for that matter. So every time I'm using attributes, I'm not supposed to write parentheses. Okay, so that's how Python identifies that this is a attribute and not method. So whenever I run this, it tells me what is the type of these numbers. It says int32. Int32 is basically integer itself. If I create some other some of you might get int64 also, depending upon the bit operating system that you are using. If it's 32-bit, you will get to see int32. If it's 64, you will get to see int64. Okay, let's try to create any other. I'll take the same. Let's take this one. Where is it? Let me create one here. My array is equals to np dot array, and let's give some float numbers: 0.1, 0.2, 0.3. Okay. My array, and let's try to check what is the d type. Okay, it says float 64. Okay, understood? So name, item size, d type. There's another two most important. One of the most important. So I'm creating this array, and there is an attribute called size. Okay, let's see if it prints anything, what is the size? What does it tell you? It tells you how many elements you have in total. Okay. And there is another important, very important attribute called shape. Okay. It tells you how many rows and columns your array has. Okay. So 4 rows and 2 columns. Yes. If you take a look at this array, you have 4 rows and 2 columns, isn't it? And if you take a look at the size, it tells you how many elements, the total number of elements you have in your array. Now, these attributes, shape, size, d type, okay, this is something, even endim also, this is something which pandas borrows from this numpy. Okay, whenever we cover this part in pandas, I will inform you that this is something which we covered. Okay, but for now keep it. इसको थोड़ा ध्यान रखना, ठीक है? Let's take a look at some more methods. Okay, let me take this again, this array again. Okay, this is creating random numbers. Yes, with normal distribution, and there is a method called reshape. Okay, now what this reshape does is, reshape is basically is used to change the number of rows and columns without changing the data. Okay, without changing the data, we can convert them from rows to columns. Okay, let's do one thing. Let's say this is 2,4. If you see, we have the same data. Yes, if you see here, we have the same data. Yes or no? But the data has been converted. The shape of that existing array is changed. If you take a look at, if I do shape now, it will say my array is equals to 4,2. I need to assign some value. Reshaped array is equals to this. And now if I check shape, it's 2,4 now. Understood? Understood, everyone? Yes? Okay. Okay, guys, let's take a break for 10 minutes here. It's 11:50 now. Let's come back by 12. Okay? Is it fine? All right. So it's 11:50 now. We'll come back by 12. Okay? All right. So is everyone back? Okay, perfect. So let's take a look at the next thing, which is slicing. Okay, for all the sequence types that we have seen, be it a list, be it string, slicing is something that we have seen for each of these data structures, right? So how do we slice it? So let's say I have an array. Let's say the array is called as quantity. And here I'll take 5, 10, 15, 20, 7, and 8. Okay. So if I ask you how to slide, now this is a one-dimensional array. Okay. So quantity dot n, if I do, this is one-dimensional array. Let's see how slicing works as far as one-dimensional array is concerned. So it works similarly, uh, just like your list or strings for that matter. So we just give the start colon stop, the start value and the stop value, where the stop value is exclusive and the start value is inclusive. Okay, so let's say if I ask you that I want only these three numbers, 10, 15, and 20. So we'll use the name of the array. What is the name of the array? Quantity, right? Yes or no? And we will give this starting index. What is the starting index? What is the index of 10 here? What's the index of 10? Yes, 1. And I want to go till 20. I mean, I want to include 20 as well. 10, 15, and 20. So what should I write here at stop? Should I write 3? If I write 3, so this is 0, this is 1, this is 2, and this is 3. This becomes exclusive. We want this to be included, right? So I will write 4 here. Understood, Siddhant? Why we are writing 4 instead of 3 here? Now, if I run this, you'll get to see all these 3 elements. Okay, so it works in the same fashion, just like your list and strings, where the start is inclusive, the starting index is inclusive, and the stop index is exclusive. Okay, now this was about one-dimensional array, which is pretty much easy, just like your list and dictionary or not dictionary, a list and string. But what if your np.array, let's say you have multiple quantities of, let's say this is pen quantity and this is pencil quantity. So let's take 2, 4, 6, 8, and 10. And here we'll take 1, 3, 5, 7, and 9. Okay. What happened? Okay, this would go as tuple. Let's check the dimension of this. This is two-dimensional array. Let's print it. Okay, so you have 2, 4, 6, 8, 10, and you have 1, 3, 5, 7, and 9. Okay. So what if I want, let's say, let's take some more values, not just two. Let's take more values in here. Okay. We'll take 11, 13, 15, 17, 19, and oops, this needs to be a tuple. 12, 14, 16, 18, 20. And let's take another tuple, 21, 23, 25, 27, 29. Okay, let's run this. Yes, 2 dimensions, rows and columns. You have how many? 5 rows. Let's keep 4 rows only. Okay. So this is 4 by 5, right? 4 by 5 matrix, but the dimension is still 2 rows and columns. 4 rows and 5 columns. Okay. Now, what I want is, I want to select all rows except first one. I want to select all rows except the first one. And as far as column is concerned, I want to just select the third and fourth column. Okay. All rows except first and third and fourth column. So how would I choose it? So I will write the name. I will write the name of the variable, okay, which is quantity. And this is where I'll slice for rows, and this is where I'll slice for columns. Okay. Here I will write the slicing expression for rows, and here I will write the slicing expression for column. Okay. So this is just a syntax. Let me write variable here. Variable name. Syntax. Okay. So if you follow the syntax, what is the variable name? Quantity, right? Yes or no? Now I want to select all the rows except the first one, right? So what is the index of this row? This is 0. Sorry, this is 0. This is 1. This is 2. And this is 3. Yes, so Harshita is right. I'll write 1 here, but I need to give a slicing, I mean the same, this colon here. Okay, and I want all the rows except the first one. So do I need to write 4 here or 5 here? No, you can keep it blank as it is. Because if you don't write anything, it automatically considers that you are going till the last index. So the slicing expression for the row is done. Now we need to write the slicing expression for columns. So which columns are we supposed to consider? Third and fourth. So what should I write here? Third and fourth. Third and fourth. We need these 2 columns. These 2 columns basically. Yes. So what should be the value here? Is it 3, Archita, or 2? This is 0. This is 1. This is 2. This is 3, and this is 4. So 2 colon 4. Correct. So again, 4 is exclusive. So 2 and 3 is second and the third column. Okay. I mean index wise. This is 2, this is third, this is 3. Now if I run this, you see, you get all the rows except the first one, and you only get the third and fourth column. Getting it? This is how you slice it. As far as this two-dimensional array is concerned. Getting it? Okay. Let's now focus on array operations. This was slicing, right? Okay. Now let's take a look at array operations. So the only array operation we have seen so far is the squaring of each of the elements of the array. Right. So let's consider this array, one-dimensional array. It becomes very easy to understand if you consider one-dimensional array. And if I want to add, instead of quantity, let's take price this time. Okay. So we will create prices and quantities. So np.array price is 120, 130, 140, 150, and 160. Okay, we have 5 values, 5 prices, and let's take quantity also, np.array. Here also we'll take multiple quantities, 4, 8, 7, 9, and 10. Okay, so these are the prices and these are the quantity of items. Let's see what is the length of prices. Yes, so how to check? We use method, we use the function independent function length, and we'll write the same thing for quantity also. The size is same, the length of both of these arrays is same. Now, if I try to perform the addition operation between price and quantity, basically I'm trying to add the elements from added array. Okay. So what I'm doing here, I'm trying to add price and quantity. If you check the result, you see, instead of quantity, let's call it as stats. Okay. And final price. This makes more sense, no? Yeah. So since the number of length, I mean the number of elements were same, it was pretty easy for to add the elements here. Okay, but if I take, let's say if I'm taking tax is equals to np.array, and let's take 4 elements here, 4, 8, 7, and 9. Okay, So let's take the length tax 4. Now let's try to perform the same operation. Let's try to perform the same operation of adding taxes to price. So what it says that operands could not be broadcast together with shapes 4 and 5. Basically what it says is if your dimensions are not similar, if the dimension of the arrays that you're trying to add is not similar, it's not same, then that operation is denied. That operation is not possible. Okay, so always remember whenever you're trying to add numbers from two dimensions, or if you're trying to add columns, okay, let's consider, let's say you have a data where you have a column called age, okay, age of employee, okay, and that data was let's say 5 years old, okay, or forget about it. Let's say you have sales data and you have two different tables, okay, you have tax cut table separately and you have price table separately, and you want to add the tax column and the price column, and you want to create a new column called final price, because final price is again used for is something which needs to be used for prediction of a price of an item. Let's say you're trying to solve a time series problem and you're trying to predict or forecast the final amount of a particular item, and you want to calculate the final price. So you might want to add two columns, right? Tax and price, in order to derive a new column called final price. In order to do that, you will have to add two columns. But if the dimension of those two columns are not similar, you won't be able to perform that operation. Why? Because this is the problem. This is the problem. And you will face the same problem. You will face the same error when you're trying to add two columns in pandas. Okay, again, the same thing. Why? Because pandas is built on top of NumPy. So the dimension has to be similar. Okay, understood? Another operation is basically, let's say you have a data, you have a column called age. Now this is the same example which I was trying to give before. Let's say you have a column called age, and this age, I mean this data was 5 years old. Now you want to find out what is the current age. What you will do? What is the age of the employee today? What you will do? Yes. What would you do? Anyone? Simply now you want to add 5 to it, right? See, the question is, let's say you have a data where you have a column where you have a CSV file and you have a column called age in it. Okay, and this data was 5 years old. You want to know what is the current age of a particular employee. What would you do? You might simply want to add 5 to that column, right? Age plus 5, exactly. Now, if we have a list, let's say age underscore list equals to 10, 12, 11. Can I add 5 to this list and expect that this 5 would get added to each of these numbers? Yes, it won't allow, right? So इसके लिए क्या सही होगा। अगर आपको लिस्ट के साथ ये एडिशन करना है 5 का इन ईच ऑफ these elements, how would you do it? You will have to write a for loop for prime range len of age list, and then for each you'll take each number, add 5 to it, and then append it again, right? That's how you would do it. Yes or no? Or you will write a list comprehension otherwise. But as far as arrays are concerned, let's say you have age array np dot array, and I'm saying 10, 15, 12, 11. So let's say this is my array. And if I want to add just a number 5 to each of these elements, I will simply say plus 5. And you will see this number 5 is getting added to each of these elements. Okay. Similarly, you will perform the same operation when it comes to pandas. If you want to add any number to a particular column, you will do it likewise. Okay, in a similar fashion. Understood this operation? Adding a number, adding a scalar quantity to each of these elements. So we saw two things so far. Basically, adding two arrays. Yes, adding two arrays is only possible if the dimension or the length of each of these arrays are similar. If it is not, it throws an error. Next, if you want to add any number, any scalar quantity to each of the element of the array, simply say plus 5. That's it. Plus that number. You simply need to use the plus operator and that number. That's it. Getting it? Similarly, if you want to multiply some number to it, simply use the multiplication operator. Let's say I want to multiply each of these number by 2. So this is how you will be doing it. You don't have to write any comprehension. You don't have to write any comprehensions here. लिस्ट में कॉम्प्रीहेंशन लिखना पड़ता है. अगर आपको ऐसे करना है तो वहां पे कॉम्प्रीहेंशन लिखना पड़ेगा या फिर एक फॉर लूप लिखना पड़ेगा. यहाँ पे हम लूप यूज कर रहे हैं क्या? नहीं. वेरी कन्वीनियंट एज कंपेयर टू लिस्ट डिक्शनरीज. ओके, नाउ let's come to the very important point, which is filtering. Okay, again filtering जो है ये इसी में आ रहा है array operations में. So let's say I have prices of some pen. Okay, np dot array, and let's say I have some numbers here: 10, 15, 20, 30, 40, 55, 60, 75. ओके, ये कुछ पेन के वैल्यूज है, कुछ पेन के प्राइसेस है. ओके, एंड आई वांट टू ओनली I only want those prices that are greater than or equal to 40. That are greater than or equal to 40. कैसे करोगे? Simply pen prices greater than or equal to 40. Yes. The problem is this only returns. Okay, please pay attention. This only, whenever you write like this, it only returns Boolean value. What it does is it compares this. Okay, देखो यहाँ पे क्या हो रहा था, ये array का नाम लिख रहे थे और +5 कर रहे थे, राइट? तो ये क्या कर रहा था, +5 जो है ये हर एलिमेंट पे अप्लाई कर रहा था. Okay, similarly here when you write this *2, it was applying this *2 on each of these elements, right? That's the reason why you get here. That's the reason why you get this answer here. Similarly, when you write it like this, what happens is Python applies this expression on each of these elements. Okay, each of this element पे it will apply this expression. Now whenever it applies this expression, देखो ये expression apply करने के बाद आंसर ट्रू और फॉल्स नहीं होगा, राइट? ये कंपैरिजन ऑपरेटर है या नहीं है? So greater than equal to 40, is 10 greater than equal to 40? False. Is 15 greater than or equal to 40? False. Yes, similarly for 30, 20, it gives false here. But when you get the right values, you get to see true values here. Yes or no? But I still need to filter out these values. मुझे ये values चाहिए. कैसे करें? Yes. See, this is very important. This is something that we will be applying in pandas, and you will have the same thing in exam also. I mean, इसका application आपके exams में भी रहेगा. So how they are going to do it? Like this. Pen prices, हमको indexing करना है, ठीक है? We will write the same expression inside this. Okay, pen prices, square bracket, pen prices greater than equal to 40. देखो आ गए आपके ये values 40, 55, 60, 75. Yes, so what it does is whenever you write it like this, तो ये जो only true values जो है ना वही आपको दिखेंगे, वही आपको आउटपुट में आएंगे, false values नहीं आएंगे. Understood everyone? See, if you write this expression and if you expect that you will get to see these values, it won't work. It will only give you the Boolean. Why? Because it applies this expression on each of these elements. Okay, but when you write it like this, basically इसके अंदर क्या हो रहा है? देखो ये अगर आप expression साइड में निकाल के रखोगे, basically यहाँ पे ये अंदर यही है ना, false, 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 true, true. ये copy paste कर दूं मैं यहाँ पे. देखो value is still the same. Yes or no? जो true values है, जो true index है, वही आपको आउटपुट में मिलेगा. I hope this is clear. So you can directly choose to write this expression in here. Okay, so ये कैसे होगा? अगर आप if you're trying to do the same thing in your data frame, let's call that data frame as df. So you will write it like this: df colon, I mean sorry, not colon, the square bracket. Here you will write the name of the data frame and the name of the variable, basically the name of the column. So let's write the name of the column as pen prices greater than or equal to 40. Okay, तो ये आपको वही values देगा. It will only show you those rows where the pen prices is greater than 40. Okay, so this helps in filtering out data from our entire table. I hope this part is clear. Perfect. All right, now you can do the same thing in your with two-dimensional arrays also. Same thing. Okay, now let's take a look at some more functions, some more methods. some more methods. Okay, I'll take the same. I'm taking the same array. Okay, and let's take the sum of the total price of these all these values. So simply what I'll do is sum of all prices. So यहाँ पे I will simply say dot sum. देखो ये ऐड करके देखो 305 आ रहा है क्या? Simply say dot sum. Okay. Then minimum price of all the pen. Yes. Same pen price, the variable name. I'll use the variable name and simply say dot min. Okay. min mean. 10 is the minimum value of all. Right. Now max, same thing, maximum price of all the pen in the array. So you will write pen prices dot max this time. Understood? फिर देखो मीन एवरेज अगर मुझे निकालना है, what is the average price of pen? Average price of pen. Yes. Dot mean करूँ करके देखो. देखो it says 38.125. Yes. देखो इसका 38.125 आ रहा है क्या? If you add these, okay. Understood all these basic arithmetic operations on your arrays. देखो सब वन लाइनर है, यहाँ पे कहीं पे भी मैंने 2 lines नहीं लिखे हैं. It's pretty easy. You just have to focus on the syntax. You just have to use the right syntax and right method name. Going forward, pandas भी ऐसे ही है. If you know what method to use, how to use it, it's very easy to manipulate data. Okay. हम Python क्यों use करते हैं instead of using an Excel sheet? When you have millions of rows, I don't think Excel उसमें काम करता है. Does it work? Let's say you have 2 million records. Let's say you have 100, 150 MB card file, CSV file. Would you be able to open it? If it opens, would you be able to manipulate the data? Yes. आपका system hang हो जाएगा पूरा. Yes or no? So you'll have to take help from Python only. तो Python में तो UI नहीं है. You don't have the UI just like you have it in Excel. Yes or no? So you'll have to use methods, functions, everything. And you guys as business analysts, be manipulating data. Definitely. You will be doing data analysis. All right. So the next part is concatenation. Okay, concatenation of array. I'll give this notebook to you, don't worry. What is concatenation? So let's create two arrays here. Let's take production day 1. Day 1 पे कितना production हुआ है? The quantities np dot array. Okay. Here let's say 11, 22, and 13. And production day 2. Let's say np dot array. Here we'll take 11, 20, and 25. Okay. So day 1 पे इतना production हुआ है, day 2 पे इतना production हुआ है. Now I want to check what is it. मतलब ये मुझे दोनों एक ही एरे में चाहिए दोनों वैल्यूज. प्लस अगर यूज करूंगा तो ये दोनों एडिशन हो जाएगा. यस, इफ आई यूज प्लस ऑपरेटर, so what happens? Addition हो रहा है, but I don't want addition. I want to concatenate them. Yes, how should I concatenate? So I will simply use np dot concatenate. ठीक है. Concatenate में क्या होगा? Now concatenate is a function. Okay, so concatenate में I will pass the list of arrays that I want to concatenate. So I'm passing a list here. देखो ये list है अंदर. Yes, it's a list or no? With these two arrays. Now if I run this, you will get to see the concatenated array. Understood? Now what if, now this is pretty easy. This was just one-dimensional array. This is one-dimensional array. What if you have two-dimensional array? Let's try to understand how to work with 2D arrays. Okay, so let's take score of layer 1. Okay, np dot array. Okay. Here take 1, 2, 3, and 4, 5, 6. Score of layer 1. Okay. Similarly, layer 2 का भी I'll take 7, 8, 9, 4, 2, 1. Okay. Now I want to perform concatenation here. क्या लॉजिक रहेगा? Concatenate करूंगा इसको मैं तो कैसे दिखना चाहिए? See, there are two. You need to understand that you can concatenate side by side. Yes, you can basically you can concatenate horizontally and you can concatenate vertically in this case. Yes or no? What if I ask you, let's see, मैं अगर np dot concatenate करता हूँ, तो np dot concatenate, and in concatenate I am supposed to pass the list of the array. So score player 1, comma score player 2. if I pass and run this, what happens here? कैसा concatenation हो रहा है? Yes. The concatenation happens vertically, isn't it? Yes or no? देखो concatenation ऐसे हो रहा है. So this is called concatenation. Concatenation along axis is equals to 0. ठीक है? This is called concatenation along axis 0. ठीक है? If you set axis is equals to 1, let me also show you concatenation along, right? np dot concatenate. Again, I'll pass the list of arrays that I want to concatenate, and here I will write axis is equals to 1. By default, the axis is 0. If you see here, by default, the axis is default is 0. You see here? Yes. Axis is 0. When axis is 0, the concatenation vertically hoga. If axis is 1, the concatenation is horizontal. Yes. So let me annotate this part also. This is called concatenation along axis is equals to 1. ठीक है, ये याद रखना, axis 0 and axis 1. This understanding is very important. What is axis 0 and what is axis 1 in terms of your data frame also. Okay. Whenever you are concatenating two data frames, you are supposed to pass these values. Okay, there is a reason behind taking this numpy. Okay, लोग numpy को usually ignore करते हैं, but it's very important to understand numpy before getting into pandas. I'm repeating it again and again. Okay, this concatenation happens horizontally. देखो हो रहा है नहीं हो रहा है, ये दो, ये ऐसे. Got it? Understood concatenation of two-dimensional arrays? It's सिद्धांत काफी fast है यार. चलो. Yeah, any doubt so far? कुछ doubt है यहाँ पे? Axis 0 is default. Exactly. Yes. Axis 0 is by default. Now, in this example, हमने एक one dimensional array लिया था और दूसरा भी one dimensional array लिया था, and we added, we concatenated these two. In this example, first array was two-dimensional, second array was also two-dimensional. That's the reason concatenation was possible. Now let's do one thing. Let's take one-dimensional array and one two-dimensional array. Okay, and let's try to concatenate them. Okay, np dot concatenate. Here I will write I will pass a list of arrays that I want to concatenate. Okay. What it says, all the array inputs, all the input arrays must have the same number of dimension. Getting it? So make sure whenever you're trying to concatenate, make sure the dimensions are same. If you're trying to do it without making sure the dimensions, concatenation won't happen. Okay, basically what it means is you're trying to add a list. You're trying to add a list, or basically you're trying to concatenate a list into a data frame. Data frame से data frame ही concatenate होगा ना? This one no, two different data structure हो जाते हैं, right? So that's not allowed. Understood? Any doubts so far? Okay, now when you go back home, what I want you to do is I want you to take a look at stack part, stacking. ठीक है? Stacking और फिर stacking के बाद revise certain topics. The first is filtering, how to filter numbers from an array. Okay. Then concatenation part. Concatenation maybe I want you to focus more on try to understand axis part. Okay. And then slicing 2D array. Okay. And if time permits, थोड़े methods देख लेना. Methods and attributes. Some methods and attributes. देखो attributes हमने कुछ 4-5 ही देखे, उसमें से भी 2-3 important है. Shape, size, ending and dtype. Okay. ये फिर से देख लेना. Methods sum देख लेना, mean देख लेना, min max देख लेना. Okay. Then a range वगैरह देखने की जरूरत नहीं है. Just if you can go through this notebook once, more than enough. A range is something which we won't be using that much. Baki otherwise, rest of these are important. All this max, mean, sum, yes, this mean, then this concatenation, all these things are important. And I don't think it's very tough. Okay, if you understand this, pandas would be a cakewalk for you. Otherwise, pandas काफी difficult हो जाएगा. Siddhant is saying axis 0 for rows and axis 1 for columns. Yes, correct. Okay. Any doubts? Any doubts? I'm done, by the way. If you have any doubts, we can discuss. If you want to talk, I can unmute you. Just raise your hand. Okay, make sure that you go through all these things. I don't think it's that difficult. Okay. Harshita is saying stacking is a separate topic. Yes, stacking is a separate topic. Very small topic. Just understand the basics of it. Any reference source. Online काफी है. Geeks for Geeks. Check out Geeks for Geeks. Okay. Just say numpy. NumPy stacking geeks for geeks. ठीक है, ये मिला हुआ है. ओके. ठीक है. उसमें 3 चीजें एक्चुअली इंपॉर्टेंट है. V split, H split and D split. Okay. Stacking maybe if you want to be specific, H split, V split, and D split. That's it. इतना ही कर लो. Okay. Baki revision, as far as revision is concerned, focus on these three things. Filtering, concatenation, and slicing. Concatenation में भी ये axis जरा अच्छे से समझ, axis part. ठीक है. Siddhant is asking, stacking is like inserting, deleting data. Yes, somewhat similar. Basically, it's used to split your data frame. Splitting a array into multiple sub-arrays. Somewhat, something like that. Okay. All right. Before we wrap up, any questions? Do you want me to share this notebook, or you have taken note of all these things? Please, can you please share anyone's email ID and share it across with everyone? Someone, please share your email ID. I'll share it with you. One second. I think I can upload here also, no, in the chat. Can we do that? होता है क्या ऐसे possible है क्या? One sec. Let me see if I can do that. Upgrade, I don't have the access to upload. Yeah, see, I have pasted it in the chat. Just check if it's accessible. I think you should have received it. Yeah, no need to email. ये यहीं से download कर लो. Okay. All right, guys. I'll see you in the next session. And also, if possible, please share the feedback for this session. Okay. It's very important. Aryan has shared the link with you guys. Just fill out the form. Won't take much time of yours. All right. Okay, then I'll see you in the next session, guys. Bye-bye. Thank you. Thank you, everyone.